You know, I'm excited because we get to go back to the hypothalamic pituitary gonadal axis. Here is our hypothalamus. And of course, the axons that project down into the portal system to send hormone locally to the anterior pituitary. So for the HPG axis, this is GnRH. You should be sick of this by now, I hope. I don't really hope. And then coming out of the anterior pituitary is going to be two hormones. I'm going to draw them. I might need to extend those arrows. Luteinizing hormone and follicle stimulating hormone. You already know this, right? But I want to now show you what this is going to do to the testes. So let's draw a piece of the testes. This isn't actually a testicle or testis. This is a cross section of the seminiferous tubules. The seminiferous tubules of a testis. And you remember that there is this lumen in the middle, of course, it's empty space, and that's where the developed sperm end up. Back over here, we have the spermatogonia, the stem cells that are going to develop into the sperm via primary and secondary spermatocytes. So in addition to the sperm cells, I also believe I mentioned there are other cells in there as well. There are Sertoli cells, and that's actually within this, like in the tube, the bulk of the tube itself. So I'm going to just draw some other cells here, I guess, that are kind of surrounding these. They're surrounding the sperm cells. They're supporting. Sertoli cells are supportive cells. I'm going to draw another type of cell that is present in the testes as well. These are located in the kind of interstitial area outside of the seminiferous, surrounding the seminiferous tubules. So these are Leydig cells. These are also called interstitial endocrine cells, because that's what they are. They're in between the tissues and they're endocrine cells. So we're going to have the actions of luteinizing hormone and follicle stimulating hormone on these different cell types. So let's just do this. Luteinizing hormone, it is going to trigger the Leydig cells. So remember, luteinizing Leydig, LL. So luteinizing hormone is going to trigger testosterone release from those Leydig cells, because those are endocrine cells, right? Let's just say these are going to produce testosterone, and that is stimulated by luteinizing hormone. Follicle stimulating hormone, it is going to, so think follicle, that's like a thing that supports something. We get to female anatomy, this name will be even more clear. Female eggs develop in a follicle. So the male equivalent to egg development is sperm development. These supporting cells are kind of like similar to the female follicle, supporting cells. So follicle stimulating hormone is going to stimulate the Sertoli cells and is going to stimulate spermatogenesis. So follicle stimulating hormone is going to stimulate the Sertoli cells and cause the spermatogonia to develop further, faster. So this is spermatogenesis. Right, that's what's genesis. You'd get it, spermatogenesis. There we go. That's what's occurring in here. It's triggering that process. So FSH is going to stimulate spermatogenesis. as we produce sperm, that's all fine and dandy. What's regulated in the system is testosterone, right? So testosterone is what's going to cause negative feedback to turn off this system. There's actually another hormone as well that's going to cause negative feedback. So Leydig cells produce testosterone. I'm going to choose my red because this is a hormone that's produced by those Sertoli cells. The Sertoli cells, well, maybe are they actually endocrine cells too? Because they produce a hormone called inhibin, which is a peptide hormone I believe I've mentioned before. Inhibin inhibits. So inhibin is going to feed back to inhibit this process as well. It actually feeds back just to the pituitary. So that way you can regulate spermatogenesis directly. So there you go. I do have a figure that shows this in a drawing not done by me. Here you go. So this is a simplified, kind of neater version. I think it's important you draw this out yourself, as I said before, but this is, if you like, kind of the neat version. This is the same thing I just said, right? LH stimulating Leydig cells, and testosterone feeds back. FSH stimulating these the seminiferous tubules that would directly be the Sertoli cells. And those are going to produce inhibin to feed back to the anterior pituitary.